Hi guys, today we're going to be looking at A-level further mathematics, October-November 2023, paper 3-2. It's a further mechanics paper, so we will start now. First question. We have a light inextensible string of length A, and it's attached to a fixed point O. The other end is attached to a particle of mass M. So the string makes an angle theta with the downward vertical through O, where cos theta is 2/3 and the particle is moving in a horizontal circle. So we have a string like this. This is O. Oops. This is O. This is the string. So it moves in a horizontal circle. Okay. There's a particle of mass M here. And this would be the angle theta. So we need to find V in terms of A and G. So for now, we can draw out the forces. So we have weight, which is mg. We have tension force, which we call it T for now. And let's resolve the tension force in vertical and horizontal. So for vertical, it would be in this direction. Horizontal, it would be in this direction. And we have an alternative angle here. So this would be theta as well. So the vertical component would be t cos theta, and the horizontal component would be t sine theta. And we know that in the vertical component, there would be no net force because it's only moving in a horizontal circle. If there's net force in the vertical component, it would start moving up and down. So yes, for the vertical component, t cos theta should be equal to mg. So we can write it down. T cos theta equals to mg, which is the weight. And cos theta is 2/3. Mg is just mg. So we know that T is 3/2 mg. And for now, we will look at the horizontal component. So the centripetal force is always the net force towards the center of the circle, which is T sine theta in this case. So we have the centripetal force of the particle would be mv squared over r. This is the formula that we can use. And the net force would be T sine theta. So mv squared over r would be the distance here. Let me draw it out. This would be the r, the radius of the circle. And how do we find that? We know that the string has a length of a, and this is a right angle triangle. So r would be a sine theta. So R is A sine theta equals to T would be 3 over 2 mg sine theta. And what is sine theta? We have cos theta equals to 2/3. So cos is 2/3. So we need to find this length. So 3 square minus 2 square, square root the whole thing, we would get sec 5. So this would be sec 5. So now sine theta would be sec 5 over 3. So I can cancel the mass here for now. And I will get v squared over a times sec 5 over 3 equals to 3 over 2 g times sec 5 over 3. And I would get v squared equals to 5 over 6 ag. So v would be sec 5 over 6 ag. It should be a positive value because v is the speed. Speed cannot be a negative value. Question 2. We have a particle P of mass 0.5 kg moving in a straight line, and the only forces acting on P are a force of magnitude 150 over x plus 1 squared in the direction of increasing displacement. That means, let's say it's moving in this straight line, and this is the initial displacement, O, the fixed point, and now this would be the direction that the displacement is increasing. So the force of 150 over x plus 1 squared would be in this direction. And a resistive force of magnitude 450 over x plus 1 cubed. So this would be the resistive force. So we need to find V in terms of x and find it in this form. Okay, so we can use the formula of net force is equals to ma, and the net force would be 150 over x plus 1 squared minus 450 over x plus 1 cubed. So this would be equals to mass 0.5 kg times A. A, we know that A can be written as dv over dt, but it also can be written as v times dv over dx. Since the question wants v in terms of x, we don't need to write it in terms of dv dt. Instead, we can use this form. So 0.5 times v times dv over dx. And now we can start to put them in terms of integration. So we can have 300 times x plus 1 to the negative 2 minus 900 times x plus 1 to the negative 3 dx equals to integration of v. So now we can start to integrate them. This would be 300 times x plus 1 to the negative 1 over negative 1 minus 900 times x plus 1 to the negative 2 over negative 2 equals to half v squared plus c. So the left side would be 450 over x plus 1 squared minus 300 divided by x plus 1 equals to half v squared plus c. So from the question, we know that when t equals 0, x is 0 and v is 20. So v equals to 20 when x equals to 0. So we have 450 minus 300 equals to half times 20 squared plus c. And c would be negative 50. And now we can sub the value of c into the equation. So we have 450 over x plus 1 squared minus 300 over x plus 1 equals to half v squared minus 50. So we would try to make v squared the subject. We have half v squared equals to, okay, now we would try to make all of this into one fraction. We would have 450 minus 300 times x plus 1 plus 50 times x plus 1 squared over x plus 1 squared. And this would be equal to 50x squared minus 200x plus 200 over x plus 1 squared. V squared would be 100x squared minus 400x plus 400 over x plus 1 squared. And this can be written as 100 times x minus 2 squared over x plus 1 squared. So now v can be plus minus 10 times x minus 2 over x plus 1. Referring back to the question, we know that x is 0 when v is 20. So if v equals to positive 10 times x minus 2 over x plus 1, v would be equals to negative 20 when x is 0. If v is negative 10 times x minus 2 over x plus 1 instead, v would be equal to 20 when x is 0. And therefore, we have v equals to negative 10 times x minus 2 over x plus 1. Question 3. We have a uniform lamina in the form of an isosceles triangle ABC, which AC is 2A and angle ABC is 90 degrees. So it's an isosceles triangle, but it's also a right angle triangle. Point D on AB is such that the ratio of DBAB is 1 over K. So find, in terms of K, the distance of the center of mass of the remaining lamina from the midpoint of AC. So to find the center of mass, we would need the mass of the lamina and the position of the center of mass. But it's not given, the mass of the lamina is not given, and we would only know the area of the lamina. And since it's a uniform lamina, we can say that the area of the lamina is directly proportional to the mass of the lamina. So we can use the area instead of mass. Let's draw a table. So we have lamina, we have area, and they want the distance from midpoint of AC. So midpoint of AC would be here. Let's call this point M. So we would want to find the distance of center of mass from this point. So this would be the distance that we want to find. Let's call it y bar. So this would be distance of COM from M. So we have lamina ABC, which is the original triangle, and we have the removed part, which is BDE. This is removed. And finally, we need to find the lamina ADEC. So we will first need to find the area. So area of ABC. So now we know that this is 45 degrees because it's an isosceles triangle. So this is 45 and this is A. And this is also a right angle triangle and also an isosceles triangle. That means VM is equals to AM. So this would also be A. So area of ABC would be 2 times half times A squared. Because half of this triangle would be half of A squared, and ABC would be 2 times half times A squared, which is just A squared. BDE would now be a more complicated one. So we know that DB over AB is 1 over K, and this ratio is also equals to, let's call this point X. So the ratio of DB and AB would be the ratio of dx to AM. It's the similar triangle concept. So we can write this as dx over AM as well. So now 1 over K is equals to dx over A, because AM is A, right? So dx would be A over K. So the area of BDE would be 2 times half times A over K squared. Why is that so? Like what we said, we know that this is also an isosceles triangle, because when this is 45, this will also be 45. So this is an isosceles triangle, and dx is equals to bx. So this would be half times A over K squared, and this whole thing would be 2 times half over K squared. So this would be A squared over K squared. A squared over K squared. And now we need to find the area of ADEC, which is the remaining lamina. And this would just be ABC minus BDE. So it would be 1 minus 1 over K squared times A squared. Okay, so now we need to find the distance of COM from M. So the distance of COM can be found using this formula. It's a triangular lamina, so we would use this. Let's put it here. So for triangular lamina, the distance of the COM would be 2/3 along the median from vertex. So this would be the vertex, and the distance here would be 2 over 3 times the length here. So we know that this is A, and this would be 2/3 of A. So the COM of ABC would be 1 over 3A from M. Alright? As for BDE, let's assume that this is the COM. So this would be 2/3 times BX. So this would be A minus 2/3 times BX. Right? So Bx, that's what we said just now, is A over K. So the distance of COM from M for BDE would be A minus 2/3 of a over k, which is 2a over 3k. And the distance of COM for ADEC from M, we now call it y bar, and we would now try to find y bar. So what we do is we multiply this minus the multiple of this equals to the multiple of this. So we have a squared times 1/3 of a minus a squared over k squared times a minus 2a over 3k equal to 1 minus 1 over k squared a squared times y bar. So we can cancel the a squared. So now we would get a times 1 over 3 minus 1 over k squared plus 2 over 3k cubed. And this is equals to k squared minus 1 over k squared times y bar. So we need to make this into one fraction. So we have a times k cubed minus 3k plus 2 over 3k cubed. And for this, we would write the same thing first. And now y bar, we can cancel the k squared, and for k cubed we can cancel it so that it becomes only 3k. So y bar would be a times k cubed minus 3k plus 2 over 3k times k squared minus 1. So we are not done yet. From this, we can see that if k is equals to 1, we have 1 minus 3 plus 2, which is equals to 0. And that means k equals to 1 is, k minus 1 is a factor of this expression. And for k squared minus 1, we know that we can make it into k minus 1 times k plus 1. So we will need to factorize the k minus 1. So using the calculator, we can find that this expression can be written as k plus 2 times k minus 1 squared, and the bottom one can be written as 3k times k plus 1 times k minus 1, and we have a times k plus 2 times k minus 1 over 3k times k plus 1. And now we are done. For part B, now the lamina is freely suspended from the vertex A, and the edge AC makes an angle theta with the downward vertical. So now it's hang freely here, this would be the vertical. Alright, this would be the downward vertical because it passed by the center of mass and the pivot. So we can imagine that it's now, so this is the vertical, we can imagine its shape like this now. Instead, this is the center of mass. So this would be the angle theta, and tangent theta would just be y bar over a. So tangent theta equals to y bar over a, and tangent theta is given as 5 over 18, and y bar is a times k plus 2 times k minus 1 over 3k times k plus 1 divided by a. So we cancel the a, and now we would have 18 times k plus 2 times k minus 1 equals to 15k times k plus 1. And now we have 18 times k squared plus k minus 2 equals to 15k squared plus 15k. So this would be 18k squared plus 18k minus 36 equals to 15k squared plus 15k. And we have 3k squared plus 3k minus 36 equals to 0. We divide the equation by 3, and we would get k squared plus k minus 12 equals to 0. Factorize it, we would have k plus 4 times k minus 3. So k is negative 4 and 3. But we know that k should be a positive value, so that the y bar here is a positive value. So we have to reject k equals to negative 4. And k equals to 3 would be the only answer. Question 4. So we have two spheres, and A is at rest, B is moving in this direction. So after the collision, they take the same time to reach a wall, and the coefficient of restitution is 1 over 2. So for A, since it's at rest now, it doesn't have any vertical component of velocity. So after the collision, it will only move along the line of centers, which means this would be VA. And for B, this is the vertical component of B, which is u sine theta. And for the horizontal component of B after the collision, let's call it VB. It would be this in this direction. So we can see that after the collision, A would travel to the right and hit this wall, B would travel in this direction and most likely hit this wall. Okay? So we will need to find VA so that we know the time for it to hit this wall, and we can use the vertical component of B after the collision to see the time for it to hit this wall, since we already know the vertical distance and the vertical velocity. So we can start finding VA using two equations. One is VA minus VB equals to negative E times UA minus UB. This is the Newton's law of restitution. So we have VA minus VB equals to negative half times U cos theta. I should write it 0 minus U cos theta, because A is stationary initially, and the initial horizontal component of velocity of B would be U cos theta. So VA minus VB would be half U cos theta. This would be our first equation. Second equation, we can use MVA plus MVB equals to MUA plus MUB. So we can cancel out the masses, and VA plus VB would be equals to U cos theta. This would be the second equation. So the first equation plus the second equation, we would get 2VA equals to 3 over 2 U cos theta. And VA is 3 over 4 U cos theta. And now we know that time A equals to the time B. So for A is traveling horizontally, and for B is traveling vertically, but they use the same time to reach the wall after the collision, right? So the time for A to travel is just the distance divided by the velocity. So we have d over VA, which is 3 over 4 U cos theta, equals to the time for B to travel is also the distance over the velocity, the vertical velocity. So it's d over U sine theta. And we can cancel the d's and the u's. So we would get 3 over 4 cos is equals to sine theta. Would be 3 over 4. So tangent theta would be 3 over 4. For part B, we will need to find the percentage loss in the total kinetic energy of the spheres after this collision. So we will need to find the final velocity compared with the initial velocity. So previously we have found the final velocity of A, and now we would need to find the horizontal component of the final velocity of B so that we can find the final speed of B. So to find VB, we can use this equation. So we have VA, which is 3 over 4 u cos theta, plus VB equals to u cos theta, and VB would be 1 over 4 u cos theta. So the speed of B squared would be the horizontal component squared plus the vertical component, which is u sine theta. So we know that okay, I would first write this u sine theta squared, and we know that we know that cos theta, we know that tangent theta is 3 over 4. So this would be 3 and this would be 4. So the hypotenuse would be 5, because 3 squared plus 4 squared square root the whole thing would be 5. So cos theta would be 4 over 5, and sine theta would be 3 over 5. So we have 1 over 4u times 4 over 5 squared plus 3 over 5u square the whole thing, and this would give us 2 over 5u squared. And the change in the kinetic energy would be half times mass, because the mass of the two spheres are the same, so we can just use m times the change in the speed squared. So initially the only speed is u squared, the only speed is u, so we can have u squared minus the speed of A is 3 over 4 u cos theta. So we would have 3 over 4 times u times cos theta, which is 4 over 5 squared, minus, and for B, the speed square would be 2 over 5 u squared. So since it's already squared, we can just write 2 over 5 u squared, and this would give us 3 over 25 mu squared. And the percentage change in the kinetic energy would be 3 over 25 mu squared over half mu squared, because initially the speed is only u, so, and half mu squared is the formula for kinetic energy, so this would be it, and we would get 24%. For question 5, we have a bit of mass m moving on a smooth circular wire in a vertical plane. So for when it's at A, it has a speed VA, and when it's at B, it has a speed VB. The beat has an angle of alpha when it's at A and theta when it's at B. And cos alpha is 3 over 5. So the reaction of the wire on bead at B has a magnitude equal to 1 over 6 of the magnitude of the reaction when bead is at A. So the reaction at B is 1 over 6 of the reaction at A. Find in terms of M and G the magnitude of the reaction at B. Okay. First off, we know that this is 180 degrees. So theta is equals to 90 minus alpha. Okay, you know what? I'll just write it down here. Theta is 90 minus alpha. That's why cos theta would be cos 90 minus alpha, and it's equals to sine alpha. So we draw a triangle. This is alpha. Cos alpha is 3 over 5, so we would have 4 here, and sine alpha would be 4 over 5. And for sine theta, it's sine 90 minus alpha, and this is equals to cos alpha, which is 3 over 5. Alright, so now we need to consider the forces at A and B. So we have weight, which is mg. We have a reaction, we call it Ra. And for weight, we need to resolve it in the direction towards the center and also perpendicular to the center. So we can resolve it in this direction and this direction. Okay, we know that this angle is alpha, and therefore we have this angle as alpha. So this would be mg cos alpha, and this would be mg sine alpha. For B, we also have weight, and the weight can be resolved in these two directions. And from this, we can know that this is angle theta, and this would be mg cos theta, and this is mg sine theta. Also, don't forget about the reaction. So the question states that the reaction of the wire on the bead, that means the reaction has a direction like this. It's going from the wire to the bead. So it's in this direction. Alright. So at A, we have, okay, so the centripetal force is always the resultant force towards the center of circle. And this means that we have mVa squared over A equals to the reaction at A minus mg cos alpha. Okay? The resultant force is, the centripetal force is always directed towards the center, and that's why we have Ra minus mg cos alpha. And we would have, oh, okay, this is equals to Ra minus 3 over 5 mg, and Va squared would be A over m times Ra minus 3 over 5 mg. At B, we have the centripetal force equals to the resultant force as well. So we have mvb squared over A equals to mg cos theta minus Rb, because the centripetal force is always in this direction. So mg cos theta minus Rb, and this is equals to 4 over 5 mg minus Rb. So Vb squared would be A over m times 4 over 5 mg minus Rb. And now we need another equation to find the values of Ra and Rb. So we can use this. The change in the gravitational potential energy is equals to the change in the kinetic energy, because the total energy in the system is always constant. So we will need to find the change in height for the bead. From A to B, what is the change in the height? So we will need to find this height, and since we know that this is A, this distance would just be A cos theta, and for this we would have A cos alpha. So height is simply just A cos theta plus A cos alpha. So we would have mg, h would be A cos theta plus A cos alpha equals to half v squared. And the v squared here would be the change in the v squared. So it has to be va squared minus vb squared. Okay, to have a clearer view, we will actually need half mva squared minus half mvb squared, because we will need the change in the kinetic energy instead of simply just the change in speed. So it's not equals to half mva minus vb squared. Okay, this is not it. So to make it easier, I would write it in this form. This is just an explanation, okay? And now we would cancel off the m, and we would have ag times 4 over 5 plus 3 over 5 equals to half va squared minus vb squared. So now va squared minus vb squared would be 14 over 5 Ag. And from the previous part, we have the equation for VA squared and VB squared. So now we can just sub these values in. Alright. So we have A over M times RA minus 3 over 5 mg minus A over M times 4 over 5 mg minus RB equals to 14 over 5 Ag. So RA minus 3 over 5 mg minus 4 over 5 mg plus RB equals to 14 over 5 mg, and RA plus RB would be 21 over 5 mg. And from the question we know that RB equals to 1/6 of RA, so RA would be 6 times RB, and 6 RB plus RB would be 21 over 5 mg, and RB would be 3 over 5 mg. Given that VA is set kAg, we will need to find the value of K now. So from the previous part, we have this equation to find for VA squared, but we would need the value of RA. So now RA is 6 times RB, which is 3 over 5 mg. So we would have RA as 18 over 5 mg. And VA squared is equal to A over M times RA, which is 18 over 5 mg, minus 3 over 5 mg. And this is equals to set kAg squared. So we have A times 3 mg equals to kAg, and K would be 3. For question 6, we have a particle P projected with speed u at an angle alpha above the horizontal from point O. It moves freely under gravity, and the displacement would be x and y with the time of flight t. So we need to derive the equation of the trajectory of P in this form. So first, we would need to find for t. We would use this equation, but in the horizontal displacement. So horizontal displacement would be x, and the initial horizontal velocity would be u cos alpha times t, and the acceleration would be 0 because there's no horizontal force. So t would simply be x over u cos alpha. And I would use the same equation for the vertical displacement. So vertical displacement is y equals to the vertical component of the initial velocity would be u sine alpha times t. Okay, I can just sub this in. T would be x over u cos alpha plus half a would be negative g. Why is it negative? Because let's say this is the flight the initial sorry the displacement would be from this point to wherever you want it to be, either here or here or here. So the vertical displacement would be going up and it's a positive value, but the gravitational force is acting downwards. That means downwards now is a negative value. So we will have negative g, and t would be x over u cos alpha squared. And this can be simplified, so I can cancel the u, and sine over cos is tangent, so I have x tangent alpha minus gx squared over 2u squared cos squared alpha. But they want it in terms of secant, so 1 over cos square alpha is equals to secant square alpha. So I can write this as x tangent alpha minus gx squared over 2u squared times secant squared alpha. For part B, during its flight, P must clear an obstacle of height h, and the horizontal distance is 32 meters from the point of projection. When u is 40 sub 2, P just clears the obstacle. That means it reaches just nice at the obstacle. And when u is 40, P only achieves 80% of the height required to clear the obstacle. So, okay, let's say it has an obstacle at this point, and this is 32 meters, and this is height h. When u is 40 sub 2, it reaches just nice at here. But when u is 40, it reaches 80% of the height. That means it's around here. And the height here would be 0.8 h. So now we have the equation of the trajectory. We have this equation, and we can just sub the values of y and x, and also u, into the formula. So first we would consider, okay, this would be y and this would be x. And first we would consider y equals to 40 sub 2. So y is h, and x would be 32. 32 tangent alpha minus g would be 10, x is 32, over 2, u is 40 sub 2 squared, secant square alpha. This would give us 32 tangent alpha minus 8 over 5. Secant square can be written as tangent square plus 1. Okay? And for the second situation, when u is 40, the height reached would be 0.8 h, the x is still 32, and g would be 10 times, this is x, and u will now be 40. And secant squared can also be written as tangent squared. So we would get 32 tangent alpha minus 16 over 5 times tangent alpha plus 1. Sorry, tangent square alpha plus 1. And so we have h and we have 0.5 h. So we can write 0.8 h. So we have 0.8 times h, which is 32 tangent alpha minus 8 over 5 tangent square alpha plus 1 equal to 32 tangent alpha minus 16 over 5 tangent square alpha plus 1. So we would have 48 over 25 tangent square alpha minus 32 over 5 tangent alpha plus 48 over 25 equals to 0. Let's simplify this equation. We can divide the whole equation by 16 over 25. So we would get 3 tangent squared alpha minus 10 tangent alpha plus 3 equals to 0. And to factorize this, we would get tangent minus 3 and 3 tangent minus 1. So tangent can now be either 3 or 1 over 3. That means we have two possibilities for the height. So the first situation, when tangent is 3, we have 32 times 3 minus 8 over 5 times 3 squared plus 1. We would get 80 meters. And the second equation, let's call this h1. And for the second equation, second value of tangent alpha, we have 32 times 1 over 3 minus 8 over 5 times 1 over 3 squared plus 1. So this is equal to 80 over 9 meters. For question 7, we have a particle attached to one end of a light rod of length 3a, and the other end is connected to a spring of natural length a. So this is the natural length, and the modulus of elasticity is kmg. The other end is attached to a fixed point. So these 2 points are 5a apart, and P is initially held in equilibrium by a vertical force F. And the particle is released from rest in this position and has a speed of 6 over 5 slip 2 ag when the rod becomes horizontal. Find the value of k. So from here to here, there's a change in height and a change in speed, and also the change in extension of the spring. So when it's here, actually no, it should be around here because the length of the rod doesn't change. So this should be 3A and this would be 2A. That means there's a change in the extension in the spring. So the height is also changing. So we know that, let's call this angle theta. We know that sine theta would be 4 over 5. Right? Sine theta is 4 over 5. And the height here is 3A sine theta, which is 3A times 4 over 5. We can save this part for later. Okay. So now we can consider the change in energy. So we know that for elastic potential energy, there will be a loss because the extension decreases. And for gravitational potential energy, it's increased because the height increased, right? And for kinetic energy, it's also increased. So there's a gain in the kinetic energy because initially it's at rest. So for the elastic potential energy, this would be the formula. And when we need to find for the change in the elastic potential energy, we will need the change in the x squared, and that means it would be x2 minus x1, sorry, x2 squared minus x1 squared, and not equals to x2 minus x1. Okay, be careful of that. So we have the modulus of elasticity as kmg and times the initial extension would be 3a, we square it, and the final extension would be a, so we also square it, over 2a equals to mgh. So h, we already found it just now. So it's equal to 12 over 5a, and for kinetic energy is half mv squared. Since the initial velocity is 0, we can just take the final velocity and square it. So we can cancel the mg, and we would have 4ak equals to 12 over 5a plus 36 over 25a. So k would be 24 over 25. For part B, we need to find F in terms of mg. So we can draw all the forces out. We have two tension force. We call this T1 and T2. And we have F. And also don't forget about our weight. So if we consider the horizontal component, we have Okay, we know that this is theta and this is 90 minus theta. So this would be T1 cos theta, and this would be T2 cos 90 minus theta, which is also equals to sine theta. So we can start doing this. For the horizontal one, we have T2 sine theta equals to T1 cos theta. So T1 is equals to T2 tangent theta. And for the vertical component, we have F plus our weight, which is mg, equals to T1 sine theta. I haven't stated it, but yes, we have T1 sine theta and T2 sine 90 minus theta, which is also equal to T2 cos theta. So we have T1 sine theta plus T2 cos theta, and T1 is equals to T2 tangent theta So now we have T2 would be the tension force due to the spring. So T2 would be the modulus of elasticity, which is 24 over 25 mg, times the extension, which is 3a, divided by the natural length, which is a. So we have 3a over a. So T2 times tangent theta would be 4 over 3 times sine theta would be 4 over 5 plus the same thing, T2 is 24 over 25 mg times 3a over a. Cos theta would be 3 over 5. So F would be 19 over 5 mg. For part C, we need to find the tension in the rod immediately before it's released. So tension in the rod, we called it T1 just now. So T1 is T2 tangent theta, right? So T2 is 24 over 25 mg times 3a over a, and tangent theta would be 4 over 3. So this would give us 96 over 25 mg.